Hi friends, welcome to my channel. Let's have a look at the newly appeared problem. Problem 2422. Merge operations to turn array into a palindrome. In this video, we're going to share three methods or formats of solutions based on first, Deque simulation, second, two-pointer, and third, the partial sums. First, I'll read through the statement of the problem to digest the task, and then we do some analysis, and finally we share the different formats of solutions. First, let's look at the statement. So we are given an array called nums consisting of positive integers. So we can perform the following operation on the array any number of times. The operation is that so we can choose any two adjacent elements and replace them with their sum. So here is an example. So if we replace 2 and 3 with their sum, so we have a result array 151. So the question asks us to return the minimum number of operations needed to turn the array into a palindrome. So this is the main statement. Let's look at the two examples. So in example 1, so the output is 2. So we can actually merge the tail elements 3 and 1. So their sum is equal to 4. Then we can merge 1, 2 again. So we get 3. So then we have the resulted palindromic array. That is 4, 3, 2, 3, 4, right? So that's the example 1. Now let's look at example 2. So in example 2, so the output is 3. So if we examine the tail, so we see that we can merge 1, 2, so get 3. So 3 is still less than 4, so we can merge 3 with 3, so we get 6. And 6 is larger than 3, but now we have only 2 elements, so we merge them together to get 10. So example 2 actually is simple but also important. So this example regarded this single element 10 as a palindromic nums array. So it tells that so for this problem, the understanding of palindrome array might be that so for symmetric position pairs, the corresponding two numbers have the same value. So that's example 2. So before we look at the methods, so let's look at the constraints or additional assumptions. First, the length of nums array is bounded above by 10 to the power 5, and also it's not empty. So this first constraint defines the problem size, and the second element constraint is on the range of elements. So it's in between 1 and 10 to the power 6. In particular, it's not negative, right? So with that said, we finished the problem statement, examples, and the constraints. So now let's look at the methods. So here we are going to present three methods. First, we'll write code for the two methods, and then we analyze and get the last format of solution. First, let's look at the key observation. So actually, for this problem, in order to turn the array into a palindrome, we always need to make sure the head and tail elements are equal. So this is actually a necessary condition. And if all these conditions are satisfied, so we will result in a palindromic nums array. So again, we want to mention that here the understanding about the palindrome array, it might be that so for symmetric position pairs, so the corresponding two nums have the same value. For example, this 12 and 12, so it's a palindrome array. So, but if we look at 12 and 12, so if we 1 and 2, this is not, right? So that's the understanding for palindromic nums array in the problem setting. So now let's look at the procedure for the first two methods. So basically the procedure is very straightforward if we grasp the key observation. So while the nums array has length greater than 1, then we're going to check the head and tail elements. So first, if the two values are equal or they equal to each other, so we pop head and tail. So in this case, so we do not need merge. So in the second case, so if the two values do not equal, so first, if the head value is smaller, then we're going to do merge from the head. So we merge the two numbers from the head onwards. So we get we need one merge operation. And if the head value is large than the tail value, so we do merge from the for the two numbers from tail. So both cases, so we are going to increment the counting of needed merge operations by 1. So we could actually simulate the above procedure using Deque. So this is actually method 1. So also we could do the check on the error. So this is method 2. So we are going to come back to method 3 after we share the code for method 1 and 2. So first, let's look at the method 1 and method 2. So first, I'm going to use a Deque to do the simulation. So this is actually very straightforward. So first, I'm going to initialize a result variable, which is the counting of needed merge operations. And then we're going to change the nums to be a Deque. So collections Deque. So this way, we can effectively pop from the left or from the right or from the head and tail respectively. And then what we are going to do is that if length of the Deque is greater than 1, in other words, have at least 2 elements, then what we are going to do, if we check the first the tail and the head elements, so this -1. So if they are equal, so we do not need merge operations. We can actually pop from left and pop from the tail from the right. So this is one case. The other case, so if they are not equal, then we can check if Deque 0 is less than Deque -1. So in this case, we're going to merge from the left or from the index from 0 and 1, right? So what we are going to do is that we get a temp variable. We need to first find the two numbers sum. So that is Deque pop left, so plus Deque pop left, right? And then what we're going to do is that we Deque so append left, right? So append left, so we're going to append the sum of the two numbers. This actually plays, these two lines plays the role of the merge. So this is let me write if. So okay, so next, so we're going to see if the Deque, the 0 is large, so we're going to pop from the tail. Let's see. So Deque pop plus Deque pop, and then we're going to append the temp. So this corresponds to merge the two tail elements. So in both cases, we're going to increment the result by 1. So after that, after we exit this while loop, so we're going to return the result state. So this is the one format of solution corresponding to method 1. So let's do a special case check first. Yeah, it passes one test case. Now let's do a generic case check. Yeah, it passes all the test cases. So this is actually the first format of solutions. So now let's look at the two-pointer method. So actually this essentially the same, but taking slightly different code format. So let's call this first one v1. So now let's use two pointers. So for this, actually, what we are going to do is that we initialize a result as in above, and then we get the length of the nums just for convenience, and then we set two pointers, left, right, to be 0 and n-1. So this is actually routine. And then we're going to do a while check. While condition is while left less than right strictly, because if a single element, we regard it as a palindromic nums array. And then what we're going to do is we do the check. So if nums 0, or not 0, left equals nums right. So in this case, in the previous solution, we popped the two number, and if we use two pointers, we just need to move the two pointers to the right direction, right, left, right. So in this condition, in this case, we do not need any merge operation. So we continue. So else, if they are not equal, then if nums left is larger than nums right. So we need to do the merge from the left, right? So first, let me stall or reserve the, or we need to merge from the right because the right is small. So nums right, and then we want to shift right to the left by 1, and then we change the value of the current right index. So nums right plus equals the temp. So this 3 lines of code corresponds to do the merge, right? So this is the one condition, one case. The other case, so nums left is smaller, so we're going to move the left to the right, right? So first, let me reserve the nums left of the previous state, and then we increment left by 1, and then the merge corresponds to increment the left by temp, right? So the current nums left actually is the sum now. So in both the two cases, so actually we need to increment the result by 1. So after that, we just need to return the final state of the result variable. So this is the second solution. So we can do a special case check. Yeah, it passes one test case. Now let's do a generic case check. Yeah, it passes all the generic cases. So now let's turn back to solution 3. So with the two formats of solutions, I feel that we have a good understanding of the procedure. So now let's look at some other analysis. So in the third solution, we're going to use partial sum of a number list. So here we're going to explain 3 items which will lead to the resolution of the problem. So first, so for a palindromic array, so the forward partial sum sequence and the reverse backward partial sum sequence are the same. So for example, if nums is 1, 2 to 1, so this is a palindromic nums array. Then the forward partial sum are 1, right, the same. 1 plus 2 is 3. So we get 3, and 3 plus 2 is 5. So we get 5, and 5 plus 1 is 6. So the forward partial sum sequence is 1, 3, 5, 6. And the backward partial sum sequence is 1, right? 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 1 is 6. So we get 1, 3, 5, 6. So we can check that the forward and the backward reverse are actually equal. So this is the first observation. The second observation is that the merge operation from the two ends. So here I'm emphasizing, so we are doing the merge from the two ends. So the merge operation from the two ends corresponds to remove one element in the forward or backward partial sum sequence. So here let's use this example. So this example also is a test case. So the forward partial sum sequence is nothing but 4, 7, 9, and so on. For example, the first one is 4, 4, right? 4 plus 3 is 7, so we get 7, and so on. So similarly, you can compute the backward. So it's 1, 4, 4 plus 2 is 6, right? If we reverse, we get this one. Then if we merge 3, for example, 3, 1 in the tail, for example, if we merge these two numbers, so the number is now is 3, is ending with 4, right? So the partial sequence actually is starting from 4, right? So in this case, it corresponds to remove this one, right? So similarly, if we merge two numbers in the height, for example, if we still use these nums, so we can merge 4 and 3 to get a 7. So we get 7. Then if we look at the forward partial sum sequence, we start from 7. So we get 7, 9, 10. Or 7, 9, 10. It corresponds to remove the first element 4 in the partial sum sequence. So this is actually an interesting observation. So the third one actually is also interesting. It connects this problem with other Leetcode problems. Third one is the final palindromic length is the length of the maximal common subsequence length of the forward and the backward reverse, right? So this actually connects this problem with the longest common subsequence sum of two nums array. So, and the needed number of merging operations is nothing but n minus l. So n is the total length of the original nums array, and l is the final length of the palindromic nums array, or the maximum common subsequence length of the partial sum sequences. One is the forward and one is the backward reverse. So for this example here, nums, and we have forward is given here and backwards is given here. So the longest common subsequence is 4, 7, 9, 12, 16. So its length is 5. So the total length is 7. So we get 7 minus 5, that is 2. So this actually explains the third method. So now let's look at the third method. So I'm going to copy this function signature and then change this to be v2. And now let's look at the third solution. So here I'm going to use partial sums and longest common subsequence of two nums array or list. So for this, we need to get the forward and the backward partial sum sequence. So this actually can be very simple. We just need to do a for loop, or we can use some libraries or functions. So let's do this. Forward. So I'm going to use the accumulation function. So let's see, tools. So accumulate. So we're going to accumulate nums, and then so this gives us an iterator. So let's make it a list. So this is the forward partial sum sequence. Now let's get the backward reverse. So it's actually similar. But let's copy this part, and then what we're going to do is that we can compute the forward partial sum sequence of the reverse. So which we will get the backward reverse. So this is the preparation, right? So now let's get the original length of nums, right? And then we are going to initialize a result as 0 or count. So let's use count. So the count will compute the length of the longest common subsequence of forward and backward reverse, and then let's use this for ig0. So the code below is find the longest common subsequence. So this is actually very standard. So while I less than m and j less than m, right? Then we're going to check if forward I and backward reverse j, if they are equal. So we're going to increment the count by 1 and then move the I and j forward. I incremented by 1, j incremented by 1. Otherwise, so else if forward, let me copy this part to avoid typos. So if this is less, let's see, if it's greater than this one, so we need to move the backward, reverse, forward, right? So we are going to increment j by 1, right? So otherwise, so we're going to move I in one step. So notice that we can use this kind of code format is due to the fact that the partial sum sequence is non-decreasing. So with that said, so we find after we exit this while loop, we are going to find the length of the longest common subsequence. Then what we are going to do is to return the n minus the count. So that's the third format of solution. So let's do a special case check first. Yeah, it passes the one test case. Now let's do a generic case check. Yeah, it passes all the test cases. So I guess that's about it for this problem. And in this video, we shared 3 formats of solutions to this problem. One is based on a Deque simulation. And after that, so we present our improved using two-pointer. And finally, we give a slightly deeper analysis. So we're going to use partial sums, and also we established a connection of this problem with the longest common subsequence problem of 2 nums array or list. So with that said, I guess that's about it for this video. Thank you very much.